Hello, so today we're going to be analyzing the energy of a tennis ball, and I want to see if I throw it from this certain height and a certain velocity. I want to see the energy it has when it reaches my dog's mouth. Ready, Remy?
All right, so let's go over the energy method of this tennis ball situation that we have. So here's our initial sketch, and we're saying that I apply the initial velocity here at 0.9 meters from the ground, and I hit it with the initial velocity of 10 meters per second. And when my dog catches it, it is at 1.5 meters in the air, and it's traveling down with a certain velocity, and we want to find what this velocity is. So going through our givens and assumptions, we know that our initial velocity is 10 meters per second. Our original height is 0.9 meters, and our final height is 1.5 meters. And we're assuming that there is no drag and that energy is conserved here. And we're going to treat our ball like a particle, and we are assuming that gravity is 9.81 meters per second squared and going down. And here is our sketch again. And to make things easy, we draw our datum line here where I apply the initial velocity so that in our first location, we have no potential energy. And then we also draw our free body diagrams and inertia diagrams, which are pretty easy since it's just when it's going through the air, the only force acting on it is the force due to gravity, which is weight. And then it is also going to be accelerating in the negative or in the positive y direction from how I'd drawn my coordinates with y, positive y going down and positive x going to the right. So for our analysis, in our beginning, we only have kinetic energy because we set our datum line there. So there's technically, we're acting like there's no height there, but it is moving. So we have kinetic energy. And in our second location, when the ball is caught by the dog, we have potential energy as it's higher from where it started, and it also is still moving when it's getting caught, so it will have kinetic energy as well. So using what we know for energy methods, 1/2 mv squared is for kinetic energy, and for potential energy we have mgh. So just plugging in our certain values of 10 meters per second for our initial velocity, and then 9.81 for gravity. And then for our height, for our potential energy, we actually have to find the difference of the two heights that we were given since we set our datum line at 0.9 meters. So the actual height would be 0.6 meters, and then we're solving for v squared. Also, we can cancel out all the masses because there's a m term in each term of energy. So we get to that final equation where v squared equals 10 squared minus 2 times 9.81 times 0.6. And if we plug that into a calculator, we find that our final velocity is 9.39 meters per second. That would be the magnitude of our velocity.